We're still in the same problem. Let f of x is equal to square root of 9 minus x squared. And our g of x that this question wants to get is g of x is equal to negative 3 plus f of x. So for letter A, write the equation for g of x in terms of x. Well, that would be now simpler. Our g of x, given the function here, f of x is equal to square root of 9 minus x squared, then just follow the given function. We have square root of 9 minus x squared, and our g of x is negative 3 plus square root of 9 minus x squared. Now for the second question, we're going to graph the given function f of x and the given function g of x for a 10 by 10 grid window. So we're given here, okay, as we did in the first part. Let's make that as our model. So we have our square root of 9 minus x squared appeared to be a semicircle with a radius of 3. So following this window, we're going to create again. Okay? We're going to create again a semicircle. So now we have a semicircle. Okay. Now let's highlight that thing. Let's highlight it. Okay, this is our f of x. How about our g of x? Now our g of x appear to be translated only translated vertically by a factor or an amount of 3 units. So 3 units down from the center. So if this is our center, we're going to count 3 units down. So 1, 2, 3. And this is our new center because it is translated. Our function, square root of 9 minus x squared, is translated 3 units down. So creating another graph for that function, we have this and this, and we'll highlight it for the same reason, just to show that it's a different function now. We have this, and this literally is our g of x, and this g of x is 3 units down. It's negative 3 plus f of x. Now be very careful with the translations. Now for the translations, you have to begin from the center, okay? And you have to move the center 3 units down, or move it to 3 units up, 3 units to the right or to the left, as is what is required. So in this case, we moved it 3 units downwards. Now describe how f of x, we'll get rid of the grids. Describe how f of x was transformed to get g of x. As you can see in this equation, or in this function, it is only translated horizontally by a factor of, or I'm sorry, vertically, not horizontally, by a factor of 3 units downwards. So this is how it looked like. And no other transformations or no other changes or movements are seen aside from this translation. Let's move on to number 6. Still the same problem, set 1-3. Our f of x is still the same, the original function, the pre-image function, which is equal to 9 minus x squared. And our g of x now is equal to 1/2 f of x plus 3. Now write the equation for g of x in terms of x. So we're just going to get our function from the given, we have 1/2 and f of x is actually square root of 9 minus x squared. We're going to have a transformation here. Our x will be x plus 3 squared. So this is how our g of x looks like in terms of the expression x as a function of x. Plot the graph of f and g on the same screen. Use a friendly window with integers from about -10 to 10 as grid points. Use the same scale on both axes. Sketch the result. So, as we did a while ago, and we're going to do it again here, we're going to sketch the graph of the original function 9 minus x square root of 9 minus x squared. So, it's like this. And so we have a perfect semicircle now with a radius of 3. Now what this graph wants us to do is to create another graph, an image function, which is mirroring or reflecting the g of x is equal to 1/2 of the square root of 9 minus x plus 3 square. Now as you notice, there is a dilation, a vertical dilation of a reduction, a shrinkage of 2, a factor of 2. So our vertical dilation would be 50% reduction of the original function. So our original function is this. We have f of x here, and to reduce this 50% or 1/2 of the given of this given function f of x, note that this function, the original function, is 3 units up. So we're going to get the half of it, so it would be somewhere in the middle of the range of this function. So we have here. And then we get a translation in the x-axis of the x-coordinate, which is 3 units to the left. Now remember, this is plus. So when you say plus, it moves to the left. When you say minus, we go to the right. Now this is a shifting or a translation of 3 units to the left. So let's count from left. From the center, we move the center 3 units to the left. So 1, 2, 3. So this is now our new center. So reflecting this height here. Okay, we're going to reflect it here. Now we get another graph, another function. Okay, with the same center, which is moved 3 units to the left. Okay, so we get another semicircle here, which looks like this. Okay, so this just messes up our thing. So we have to remove that, and then get another sketching of a graph here. And then I need to highlight that to show you that this is another function, and this is, I want green. Okay, so we have now a different function, g of x, which is graphed. Now for you to be able to see it clearly, I removed the grids, and this is our g of x. Now describe how f of x was transformed to get g of x. What did we do to our f of x here? Basically, the first thing that we did is we reduced our function our original function f of x, our pre-image function f of x, to 50% of its original size. Why? Because it's reduced by a factor of 2. And that means a dilation. It was dilated by a factor of 50% or 2. So we move this thing here. We move these coordinates here by half of it. So from here, from the origin, 1, 2, 3, and 1/2 of 3 is 1/2. So we remove it here, and we basically just add a reflection. We reflected it for the new graph, so it's reflected in here. Okay, and then we did translated the function 3 units to the left, because x plus 3 means that it should go to the left, and x minus 3, for example, will go to the right of the y-axis. Now we have x plus 3, so it went to the left, y units or 3 units to the left of the y-axis. 3 units from this axis. From this axis. Okay, this is our y-axis. We moved it 3 units. 1, 2, 3. Okay. So those are our answers for problem set number 1-3. For numbers 2, what's the other number? And for numbers 1 and 6. Thank you for watching.